Welcome to renovating a Stuart 5A twin steam engine. This is part 3, replacing some taper pins in the valve gear and dismantling engine parts. You've just seen the taper pins that I bought because there was some missing. These taper pins are a little bit chewed up, so I'm replacing as many as I can with new ones. This is a new one as opposed to the old one on the left. When fitting taper pins, it is really difficult to get the hole to be the right length. The hole, of course, is tapered, and when you put the taper pin in, some of them go down further than others, unless you mark out on the actual reamer and get it dead right, and in reality that doesn't happen. As you can see, this taper pin doesn't go in very far, but the one on the right has gone in much further down. And the only solution to this, really, is to either totally dismantle the unit, re-ream the holes, I'm not going to do that, or mark them, and I'm using a needle file here, and cut them to the correct length. In some cases you can cut them in situ because the metal is quite soft, and a pair of side cutters would probably work quite well. Removing small taper pins like this is usually quite straightforward. A couple of very gentle taps with the hammer should do it. I cannot stress the importance of using very light hammer taps on these pins. If you're going like a bull at a gate, then you're likely to smash the part that you're trying to repair. You have to have a certain touch for model engineering. For refitting the taper pins using a small hammer, again you have to be very gentle with them. They've now been cut to size, and it's only a case of seating them in the taper hole, and this really does not require much pressure. Turning the engine around now, I'm repeating the process on the other side, once again using the needle file to mark them out, and then as before I will cut them to length over the correct area of the taper pin, and refit them by tapping them in with a hammer. Again using very little force with the hammer on the parts. It's also important not to hit any other part of the engine with the hammer, and sometimes you can do it this way using the hammer on the side. But once again, very small hammer blows, just a gentle tap. I think I do detect a little bit of play there. This engine is very well made, but a lot of the parts are left as cast. All the necessary machining's been done, of course, for instance the oil hole in the centre of the casting. I have a bit of a problem here. There is not a hole through this part for me to put this taper pin in, no matter how hard I look, and at first I thought I was seeing things or not seeing things. But when I look closely, and you can't really see it from the video, there is a pin already in here that someone's filed flat. I have a decision to make. Do I dismantle all the valve gear to re-drill and re-ream the taper hole, or do I live with it the way it is? Moving on to the other side, there's a little bit of a problem. If you look at the taper pin on the right hand side, you'll see that underneath it's slightly bent. Someone's had a go at getting this out with quite a lot of force. So what I'm going to do is leave that where it is and just fit a new taper pin at the other side. The main thing is now that all the valve gear is very secure. There's no danger of any of these arms dropping off when the engine is running. In this last section about the fitting of the taper pins, I'm just filing the other taper pin to make sure it's not sharp. This clip shows me removing the top cylinder covers to just get them out of the way, because I've just painted them and I don't want to damage the paint, because now I have to take off the cladding. The outer cladding is in the form of 2 pieces of shaped steel sheet, and these are held on by 6 BA bolts, and I'm currently removing these so I can get the cladding out of the way. In this clip you will see that there are 3 notches filed into the top of the cladding sheet. I've noticed on this engine there are odd notches filed into things. The parts are not numbered, it's some code that the builder must have put in there so I knew which way the engine went back together. I think if I'd have built this engine though, I would have put the marks underneath so they're not quite as visible. At first I thought these marks were damaged because they do occur in various places throughout the engine, so I assume they are marks put there by the builder to identify where parts go. This system of fitting the cladding is the same on all Stuart models, well, most of them. You get a thin piece of steel sheet that has this chemical black surface on it, which you bend to shape and fasten to the cylinder. And once I remove the piece of outer cladding, you can see that there is some sort of fibrous inner cladding. You have to be careful working on old engines because sometimes this stuff can be asbestos. But this is not a really old engine, and this doesn't look like asbestos, and it doesn't smell like asbestos. Nor does it taste like asbestos, so one assumes that it is not. It's a more modern equivalent. Looking at the past though, asbestos was really good stuff. Not really good if you breathe it in and die, but really good stuff for heat insulation, and was used extensively on full-size steam engines and on quite a lot of model engines. It would not be right to make any jokes about asbestos because people are still dying from handling it many years ago. And the modern equivalent is okay really. It's not so good in graphited yarn, but it's okay on insulation. Modern asbestos substitute, I do believe, is a byproduct of the China clay industry, or it's made from China clay in some way. That's it for now. Thanks for watching, and I hope you found it useful.